Okay, guys, let's start. Today we will do the practice session for chapter 5 and also Tuesday next week. Okay, so these two classes. This is the list of the question we're going to go over together. Okay. So for chapter 5, mostly all about confidence interval, depending on the sample size is large or small, or it is for confidence interval of population mean or proportion of difference between two means and so on. Okay. Okay. So let's look at the first question, number 1. Okay, on page 336, question number 8. Okay, so which is here. As I said, always look at the last sentence. Okay, so for A, it is asking 95% confidence interval for the mean surgery time for this procedure. Okay, so this is confidence interval for mean value. Okay, and then we should figure out if it's for large sample or small sample. Okay, so the sample size is 123, and so we know this is large sample. Okay, let me write down the equation. So this is first question. Large sample, CI for population mean. Okay, so, and this is for any type of distribution. Okay, and the equation I also copy here. Okay, this is the equation 5.1 on page 327 on your textbook. Okay. So the confidence interval is this, the mean value, because this is large sample, we use z value, z alpha alpha. S is the sample standard deviation, and N is the sample size. Okay. In a moment, we're gonna show the equation for number 2, which is small sample confidence interval for population mean. Okay. Right. Look at part A. Okay, so let's read the question first. So one article, application of surgical navigation of total hip arthroplasty. Okay, so by author in that journal, okay, report that a sample of 123 hip surgeries of a certain type, the average surgical time is 136.9 minutes. Standard deviation 22.6 minutes. Okay, so A is for 95% CI for the mean time. Okay, so using that equation, the mean 136.9, sample standard deviation 22.6, sample size 123, and for G alpha alpha, okay, because this is 95% confidence interval, alpha is 100 minus 95%, this is 0.05. So half alpha will be 0.025. Okay, so we have done this so many times. Okay, so 0.025 is half alpha, and from the Z table, okay, Z half alpha will be 1.96. So this is table 8.2. Okay. So plug in this number into the equation here, okay, we can figure out an answer. Okay. So 136.9 plus minus the half alpha 1.96 s square root of n. Okay. So the range is this. Then part C of this question. So a surgeon claims that the mean surgery time is between 133.9 and 139.9 minutes. Okay. So what level of confidence can this statement be made? Okay. So we use the same question, but we calculate backwards. Okay. So again, we use this equation. The range tells us is 133.9. Okay, so lower bound is that. The lower bound is that. So, and the upper bound is 139.9. Okay, so we let, for example, we choose the upper bound, 139.9 is equal to the mean value, 136.9 plus the half alpha. Okay, so we do not know the confidence interval because it is related to half alpha. Okay, so the half alpha s doesn't change, 22.6 square root of 123. Okay, so based on this, we get the half alpha, which is 1.47. Okay, and then let's figure out what is alpha. Okay, we use table 8.2. So this is table 8.2, the z table. For z half alpha of 1.47, 1.47 is here. Okay, so yeah, I cannot highlight, but 1.47, it is 0.9292 is here. Okay. But remember, for z table, that's the area to the left-hand tail. Okay, so the area to the right of z of 1.47, okay, will equal to 1 minus 0.9292. Okay, so which is 3.0708. Okay. So half alpha is 0.0708. Okay. So 1 minus alpha, which is the confidence interval, confidence level. So 1 minus 2 times of half alpha, which is 85, around 86%. Okay, so the level of confidence is 86%. Again, we use the same equation, we calculate backwards. So that is part C of the first question. Then part D. Okay, part D is asking roughly how many surgeries must be sampled. How many surgery must be sampled? That's about n, sample size n. so that 95 confidence interval will specify the mean to be within plus minus 3 minutes. Okay. Again, same equation. Okay. The half alpha right now will be 0.0025. Okay. So from table 8.2, we know that already. So that's 1.96. Okay. So 1.96 times S, standard deviation, doesn't change, 22.6 or square root of n is the sample size. So that is equal to 3 because the question tells us within plus minus 3 minutes. So z half alpha times S over square root of n equal to 3 minutes. So with that needs to be equal to 3. So we figure out n is around 219. 219. Okay. So that's the first question. The second question is all about, also about population mean, but for small sample. Okay. The question is page 354, question number 12. Question on the book first. Okay. So that is in section 5.3. Here. Okay. So question number 12. It's here. Write this down. Question number 2 is small sample. Small sample CI for population mean. And the equation is here. Sample size, sample mean plus minus. So small sample, we know is already, we use t value from students' t distribution. And for t value, we have 2 parameters. One is the degree of freedom, the other one is half alpha or alpha. Okay. Then S, sample standard deviation, and n is the sample size. Okay. So this is table 8.3, the t table. Okay. So I also write down the equation number, equation 5.9 on page of the 349 on your textbook. Okay, so this is the equation. And you can.
I set your alarm for 3:10 p.m.
And you can compare question number 1. So large sample CI for population mean, this, and small sample CI for population mean. Okay. So actually you can write this equation side by side in a single paper. Okay. Let's read the question together. This is question number 12. Okay. Again, always read the last sentence. 95% confidence interval for mean penetration resistance. For the mean penetration resistance for this soil. So mean value, then let's look at the sample size, is big or small. Okay, so read the question, article. Okay, so influence of penetration rates on penetrometer resistance. Okay, a journal paper, present measures of penetration resistance for a certain fine-grained soil. Okay, 15 measurement of 15 small sample because it is less than 30. So 15 measurements expressed as multiple of a standard quantity give us the mean value 2.64, standard deviation 1.02. Okay, so from there we know this is a small sample confidence interval for population mean, and we use this equation here. Okay. Just get parameters from the question. Sample mean 2.64, sample standard deviation 1.02, sample size is 15, small sample. Okay, then for t value, so t is n minus 1, so 15 minus 1, so the degree of freedom is 14. Okay, half alpha based on 95% confidence interval, the half alpha again is 0.025. Okay, so that's the t value. Okay, so let's figure out what is t value is. Okay. Let me get the table for you first. Sorry, something wrong. Okay. Just give me a second. Okay, here we go. Okay, this is the table 8.2. Here is the T table, table 8.3. So degree of freedom is 14, right? 15 minus 1. 0.025. So the value is 2.145. Okay, sorry, I cannot highlight here. So 14, 2.025. So 2.145 is here. Okay, so from table 8.3. Then just plug in the number 2.64 plus minus t value 2.145 s given 1.02 square root of n, 15. Okay, so that is equal to okay, so that is confidence interval. Okay. Okay, so that's the answer for question number 2. Okay. So question number 2 is from section 5.3. Okay. Question number 1 is from section 5.1. Okay. I discussed these two questions together because I want to compare, the difference between them. So both these two questions, these two equations, is about confidence interval for population mean. One is large sample, the other one is small sample. Okay. So the third question is from section 5.2. Okay. So page 344, question number 15. A and B. Okay, question is here, number 15. Again, look at the last sentence of the question. Part A, 90% confidence interval for proportion. Okay, so confidence interval for proportion. That is section 5.2. Okay. CI for proportion. Okay. Let me write down the equation. So confidence interval for proportion is between 0 and 1. So cannot be less than 0 and cannot be larger than 1. So sample proportion plus minus C half alpha. And this is modified P. Okay. And modified N. And the modified P and N equation is here. Okay. So that is equation 5.5 from page 340 in your textbook. So let's read the question together, number 15. Article, a music key detection method based on pitch class distribution theory. Okay. Describe a method of analyzing digital music files to determine the key in which the music is written. In a sample of 335 classic music selection, the key was identified correctly in 293 of them. Okay, so 293 over 335 is the sample proportion. A, asking 90% CI for proportion of piece, for which the key will be correctly identified. Okay, write down the number. So X, 293, and okay. And the modified P is X plus 2 over N. N is modified N, which is 335 plus 4. Okay. So based on this equation, so 2.87. Okay. For 95% and 90% confidence interval, so Z half alpha, so that is Z 0.05. Okay, half alpha is 0.05. From table 8.2, that's 1.645. Okay, 645. Then we can just plug in the number into the equation here. So sample proportion 2.87021 plus minus Z half alpha 1.645 square root of modified P times 1 minus modified P over modified N and then you can calculate the range. Part B. So part B is asking how many music pieces. Okay. So how many music pieces? This is a question about N. Okay. Again, use the same equation, but we calculate backwards. Okay. That's part A. Part B. So let's define N is the sample size. Okay. Then the number N need to satisfy the equation of this. Okay. So within plus minus 0.025 with 90% confidence. Okay. So 0.025 will be equal to, because this is 90% confidence, the half R is still 1.645. Okay. Square root. Okay. Just copy the equation here. Okay. Because the modified P should not change. So modified P is still the same, 0.87021. Okay. The only thing change is sample size. Okay. So 1.645. We can get N so which is around 486. Okay, don't forget the modified n is equal to n plus 4, n plus 4. When you get modified n, you need to minus 4 to get n. Okay. Right. Again, use the same equation, but calculate backwards. So that's the equation for proportion. So the next question is 358.
Hi, Professor. I actually have a question about that last part.
Sure.
Since we're finding the sample size and you said the P doesn't change.
Yeah, because it didn't say the P will change. So we just assume.
But wouldn't it?
Yeah.
Even though P is dependent on on N, it still stays the same.
Yeah. So we don't change the P, but just change the sample size. Okay. So the proportion doesn't change. Okay. The only thing change is the sample size. Okay. Because there's no
right, but isn't
proportion. Yeah.
Because isn't the proportion also dependent on the sample size?
It is depending on the sample size. But if the proportion does not change, then the number of correctly identified will also be increased. Okay.
Okay.
Yeah.
Okay, I think I get it now.
Okay. Thank you. Yeah. Okay. So the number 4. Number 4 is from section 5.4. Okay, so this is large sample confidence interval for difference between two means. Okay, so let's get a question first. Section 5.4, question number 6. Okay, it's here. Again, here is CI for difference between two means. And depending on the sample size, we have two sets of equations. Let me write down this first. Okay. So if the sample size is large, and for large sample is n larger than 30. Okay. And that's the situation from section 5.4, and the equation is here. So mu x minus mu y equal to sample mean for x minus sample mean for y plus minus c half alpha. Sigma x squared, so standard deviation for the population. So if sigma is not given, we can use sample standard deviation, S, instead. Okay. So let's see, or sample standard deviation if sigma is not available. That is equation 5.16 from our textbook on page 357. Okay. So this is a large sample. For small sample, okay. So n minus n less than 30. So that's from section 5.6. Okay. So again, I put these two equations side by side, so you can see the difference. So mu x minus mu y. The difference is instead of using z value, we use t value. Okay, you know that already, I guess. So sample mean x minus y, so plus minus t value. For t value, we also always have two parameters. One is the degree of freedom, and the other one is half alpha or alpha. If it's asking for an upper bound or lower bound, we should use alpha. Okay. Okay. So the only difference is the one is using t value, the other one is use z value, and the degree of freedom, they have a very long equation. Okay. I will not copy here, so you can write that down. So that's two equations for difference between two means side by side, one for large sample, one for small sample. Okay, so go back to question number 6. Look at the last sentence, 95 CI for mean difference. So mean difference is difference between means. Okay, so we have two equations to use depending on the sample size. Okay, so read the question. A group of 78 people. All right, the sample size is larger than 30. So we use this equation. Okay, as you can see, chapter 5 is pretty much straightforward. Okay, so many equations, but it's very easy to figure out which one to use. So a group of 78 people enrolled in a weight loss program that involved adhering to special diet and to a daily exercise program. After 6 months, the mean weight loss was 25 pounds, okay, with the sample standard deviation of 9 pounds. A second group, 43 people, so also larger than 30, went on to the diet but did not exercise. After 6 months, the mean loss was 14 pounds, the standard deviation 7. Okay, all right, so the mean value for one group okay, one of them is 14 pounds. Standard deviation is 7 pounds. Sample size 43. Another group, the mean value is 25 pounds. Sample standard deviation 9. Sample size is 78. Okay. So Z half alpha, depending on CI, so 95% CI, so half alpha is 0.025. So Z 0.025 is equal to 1.96. Okay, so table 8.2. Then just plug in the equation here. Okay. So 25 minus 14 plus minus 1.96. Sample standard deviation 7. Sample size. Another standard deviation 9. Sample size. Okay. Okay. So that is question number 4. Okay. All right, let's do one more question today. Okay. I think we can comfortably finish all this question by next time. So let's do one more, question number 5 today, and leave the remaining question for next time. Okay. So number 5 is on page 371, question 14. That is from section 5.6. Is here. Okay. So again, look at the last sentence, 95% confidence interval for the increase in bacterial efficiency. Okay, the increase, from old to new, that is same thing about difference. Okay, so that's the difference between two mean value. Okay, the sample size can be figured out from the question. Okay, so let's read the question together. In a paper, which is bacterial properties of flat surface nanoparticles derivatized with alkylated polyethylene, I cannot really pronounce that. So experiment was described in which alkylate polyethylene were attached to the surface and to nanoparticle to make them bactericidal. Okay. All right. It's hard to understand what does that mean. In one series of experiments, the bactericidal efficiency against the bacterial E. coli, okay, so basically means how effective to kill the that type of bacteria, was compared for methylated versus a non-methylated polymer. There's two type of polymers. Okay. All right, two type polymers compare the efficiency to kill the bacteria. So that's the paper about. The mean percentage, so that's the mean value. So the mean percentage of bacterial cells killed with methylated polymer was 95. Okay, the mean value for one of them is 95. Standard deviation is 1. The mean for another method is 70 with standard deviation of 6. Okay. All right, here is the sample size. Assume that 5 independent measurements were made on each type of polymer. So 5 is small sample. Okay. So we can zoom in this equation. So small sample, confidence interval for difference between two means. Okay. All right. So the t value, we have degree of freedom. The equation for that, let me just copy it here. Sx squared and x Square. Okay, so degree of freedom is a function of sample standard deviation for x and y, and the sample size of x and y. Okay. Okay. Oh, by the way, let me write down the where you can find the equation. That is equation number 521 on page 366 of your textbook. Okay. Simple mean for one of the polymer 95 SX 1, sample size 5. The other mean 70, standard deviation 6, sample size is also 5. Okay, so degree of freedom, again using that long equation, I will just skip the details. It is around to 4. Okay, remember that's rounded to the nearest integer. Okay, so rounded to the nearest integer, around 4. Okay, so 4 is the degree of freedom. Half alpha is depending on confidence interval. So that is 95% confidence interval. So half alpha is again 0.025. Okay. Here. For degree of 4, freedom of 4, half alpha is 0.025. Okay, so that's 2.776 from table 8.3. Okay, 2.776. Okay, then what we should do is we just plug in the equation here. Okay. 95 minus 70, okay, here, plus minus t half alpha, 2.776, square root of sx, 1. Sorry. Square over sample size is 5. Okay. So sy is 6, square over sample size is 5. All right. So the answer is here. All right. So for 95% confidence interval, okay, for the difference between two means is 17.4 and 32.56. Okay. Okay, let's stop here today, and we'll finish that remaining questions next time. Oh, by the way, I also assign you the homework for chapter 5. You have 3 weeks to finish. Okay. Okay. Any questions before we dismiss today?